Hello, in today's video we're going to be talking about limiting reactants. Now, in order to identify and understand what the concept of a limiting reactant is, it's easier to see a simple example that doesn't use chemistry and then move on from there. So I'm going to show you a simple example today, and then your textbook also has a very good example using ice cream. But for the example that I want to use today, I want to use building houses. So let's start just by the simple 3 building materials that we're going to use to build a house and what a house entails, what parts of a house we want. So we're going to need every house to have a base, we're going to need every house to have a roof, and we're going to need every house to have a door. So this is our concept of a house, okay? This is going to be considered our product. This is what we want to make. Now, in order to do that, we're going to have starting amounts. Those are going to be considered reactants. So let's say we have 4 bases, 5 roofs, and 3 doors. How many houses, complete houses, can I make? Well, we could just go down the list and we can see. First, we know that we can draw 4 bases. This seems to be that we could make 4 different houses. Each one has a base, that's great. So starting with one reactant, we can't really tell which one's limiting, which one's in excess. Next, let's add roofs. This house gets a roof, this house gets a roof, this house gets a roof, and this house gets a roof. Now we actually have 1 extra, because there were a total of 5. Each house only needs 1 roof, so now we have an extra. So without considering the doors, if our houses were only composed of roofs and bases, the bases would be the limiting reactant, and the roofs would be the excess reactant. Let's add in the doors. This house gets a door, this house gets a door, and this house gets a door. So now we can see that the first 3 houses are complete. They look just like this one. So these are our reactants, these are our products, and we know that we can make a total of 3 complete houses. This house does not have a door, so it is not a complete house. This house is not a door, doesn't have a door, does not have a base, so it is not a house. So if we look, we can see which ones are in excess and which ones are limiting. The one that ran out first is our 3 doors. This is called your limiting reactant. The bases, we had 1 extra, so this is an excess reactant. The roofs, we actually had 2 extra, so this is called an excess as well. Generally in this class we're going to be doing reactions that only involve 2 reactants and 2 or more products. So this has actually 3 reactants to form 1 product. It's kind of a different type of a problem. So with this is a simplified example of what a limiting reactant is. If we were able to draw all of the molecules, we could actually see how many of each type of atom are left over. So let's move away from houses. This is what a limiting reactant is. This is excess reactant. Let's move into something more chemistry based. So I'm going to give you guys a balanced chemical equation. It's going to be the combustion of methane. CH4, methane is a gas. We're going to combust that with oxygen gas. This is going to produce CO2 gas and H2O, liquid. In this case, this is not a balanced chemical equation. We need a 2 in front of the oxygen and a 2 in front of the water. Let's say that I started with 1 mole, 1.0 moles of methane, and I combusted that with 1.0 moles of oxygen. How much product can I produce? That is the way that limiting reactant problems are stated. We are given the starting amounts of both reactants, and we want to see how much of a single product we can make. Now, in this case, I didn't say which product I wanted, which means you could convert both of these into one of the products, either CO2 or H2O. In this case, let's see how many moles of water 1 mole of methane can make. We know how to do this through our conversions. For every 1 mole of methane, we have 2 moles of water, which gives us 2.0 moles of water. That means for every 1 mole, for our starting amount, we can make 2 moles of water with this methane. If we do the same for oxygen, we have 2 moles of O2 for 2 moles of H2O. This gives us 1.0 moles of H2O. In this case, 1 mole of oxygen can only produce 1 mole of water. So since the reactant of oxygen can produce the smaller amount of the water, this is called our limiting reactant. Because once we make 1 mole of water total from this, all of the oxygen is used up, we don't have any left over. But we will have excess methane. So this is a very simple type of a limiting reactant problem. We start out with 2 different reactants, 2 different starting amounts. We convert them to a single product. It doesn't matter if it was CO2 or H2O, we would have gotten the same results. Whichever one produces the least amount of product, that reactant is going to be considered your limiting reactant. We will go through a bunch of these problems tomorrow in class, and I will see you all in class tomorrow.